All right, my name's Jose Garcia, and my lab partner for today was Jonathan Armstrong, and we created a self-sustained substation security system. First off, we used the microcontroller, the Parallax Propeller Activity Board. This board will use a C language and also has multi-cores. The multi-cores allows us to run multiple functions at the same exact time without having to wait a sequence. For the substation, we designed a 4-quadrant sensor to where we have 4 different sectors upon which we will have a sensor detecting each sector. Now the sensors are infrared sensors and they're located in the corners of the substation. So once an intruder comes into a certain sector, the sensor will tell the microcontroller that there is an intruder inside of its sector. If for some reason we would need to do maintenance on the substation, there is also a gate code operation that allows for the special code, 8-digit code, to be entered in order to allow maintenance work to be done on the substation. Once the work is done, the alarm system can be reactivated by mixing up the numbers of the code. The actual camera system is a very simple kind of system to where we just mount the cameras on top of servos, and once an intruder is detected inside of a sector, the servo will turn a certain amount of degrees to the sector upon which the intruder is located.
Here we can see the dual axis servo solar tracking system that I created. I used a 4-quadrant system consisting of 4 LDRs that are separated by borders as seen in the picture. This allows me to isolate which LDR is seeing the light from given directions. We can also use comparisons for left, right, up, and down to determine which direction the greatest amount of light is coming from. For this system, I used 2 high-torque servos. The top one is driving 2 steel piston rods that control the solar panel's pitch in the vertical direction. Underneath this system is another servo that is mounted that allows it to turn it in the horizontal direction. The top part of the solar panel is sitting on top of a lazy Susan bearing. I ended up having to use the Max 32 only to display the voltage and the power. In this part, I used voltage divider to step down or measure a smaller voltage, since the Max 32 can only allow a reading of up to 5 volts and the solar panel can output up to 23 volts. Here we have the demo videos. This first one is the solar panel. As you can see, it's moving away from the greatest amount of light until all 4 of the LDRs see the light at the exact same time, and it will pause. Here's the output of the voltage in the room at the time.
And here we have the demo of the substation. As you can see, we have the gate, and here is the gate code that would allow us to enter the gate when maintenance was needed. I just activated the system there, actually deactivated it. And here we have our cameras, and they are turning to angles depending upon which an intruder is seen. So we can see the system is now working, and the cameras are facing one of the quadrants where they sense the intruder. Now this is a little sensitive due to the cameras also seeing my movement across from it. But as we can see, we have the sensor, and each one of the corners of the substation. And now we're gonna see the cameras move right now as well. So when they detect a motion in more than 2 sensors on each of their sides, they will go into a neutral position. And as you can see, if they have multi-area sensors, then they will also go crisscross to their nearest location to see the intruder.